Hello friends, welcome to my channel Academic Made Easy PC. If you have not subscribed my channel, subscribe it and also click the bell icon. Question 12. Let matrix A and matrix B given. Verify that A B the whole inverse is equal to B inverse into A inverse. So now first we have to take AB, then we have to take the inverse of A into B, and then we have to check whether B inverse into A inverse is equal to these two. So now let's move on. First we will be finding the matrix A into B only. So now let's start. So A into B is equal to, so now let's start multiplying the given two matrix. So since both the matrix are 2 by 2 order, so the final matrix also will be 2 by 2 only. So first let me take the rows of the first matrix. So I will be taking it twice. Why? Because I have two columns over here. Now I will start multiplying with the columns now. So now I will add. So A into B is equal to 767, 87, 47, and here it will be 61. So this is my matrix A into B. So now I have to find A, B inverse. No, so first I have to find the determinant of A, B. I have to check whether inverse exists or what. So determinant AB is equal to 67, 87, 47, 61 determinant. So I will be using the X method. So 67 into 61 minus 47 into 87. 67 into 61 is 4087 minus 47 into 87 is 4089. So what is the answer? Minus 2. So since it is not equal to 0, inverse exists. So now I have to find the adjoint of A into B. So adjoint of A into B is equal to, so I will be, this is my determinant now, so I will be swapping these two. So 61, 67, and I will be changing the signs over here. Minus 87 minus 47. So this is my adjoint. So now I will take the inverse. A inverse is equal to 1 by determinant A into adjoint of A. So what is determinant? Minus 2. Adjoint is 61 minus 87 minus 47, 67, isn't it? So finally I will write, you can leave it till this step or else you can take the minus sign inside. So A inverse is equal to 1 by 2 into minus 61, 87 plus 47 minus 67. So let this A be the whole inverse, no? Be the whole inverse. So B. So this is equation 1. So the second part is now my RH is no. So first I have to find B inverse. So what is my B? So my matrix B is 6, 8, 7, 9. No. So first I will be checking whether it has inverse or not. So if I do 6, 8, 7, 9. So doing with X method I will get B is, here it is 54 minus 56. So it is minus 2. So now my adjoint of B. So here I will be changing these two elements. So 9, 6 minus 8 minus 7. So now my B inverse is equal to 1 by determinant B into adjoint B. So 1 by what is the determinant? Minus 2. So into 9 minus 8 minus 7, 6. So I will be taking the minus sign inside. So 1 by 2 into minus 9, 8, 7 minus 6. So let this be equation 2. Now let's find for A. So what is our matrix A? 3, 7, 2, 5. No. So first let me find the determinant. So determinant is 3, 7, 2, 5. So I will be using the x method. So 15 minus 14 is equal to 1. So now adjoint of A is equal to, these two elements will be swapped and this will get, so this is the adjoint. So now A inverse is equal to 1 by determinant A into adjoint of A. So now what is the determinant? My determinant is 1. So adjoint is 5 minus 7 minus 2, 3. So A inverse is equal to 5 minus 7 minus 2, 3. Let this be equation 3. So now I will be finding B inverse into A inverse. So this is my A inverse. So now I will keep this half as it is, and here I will be taking the first column rows alone. So I will be multiplying with the columns. So here it will be half of, here it is minus 45 minus 16, here 63 plus 24, 35 plus 12, and minus 49 minus 18. So half of minus 61, and here it is 87, 47, and here it is minus 67. So let this be equation 4. So if you check equation 1 and equation 4, the two equations are equal. So it is proved that, so it is verified that AB the whole inverse is equal to B inverse into A inverse. That's it. Question 15. If A matrix is given, then show that A square minus 5A plus 7I is equal to 0. That is 0 matrix. Hence, we have to find the A inverse also. So now first, we have two parts in the question. So this will be the second part. So first we will be proving the first part. Then we will find the second part from this first part. So here finding A inverse is little different from the previous sums. So you have to listen very carefully. So first let us do this equation. So these types of equations are familiar to us. So let's start doing. So A square is equal to A into A. No. So A square is equal to, so this will be my matrix 1. This will be my matrix 2. So I will be taking the rows from the first matrix. So I will be taking it twice. Why? Because I have two columns. So plus 1. So now I will start multiplying with the second matrix. So I will be multiplying with the column. So first element with first column, second element with second column. 3. So now we will be calculating. So 9 minus 1, 3 plus 2 minus 3 minus 2 minus 1 plus 4. So 8, 5 minus 5, 3. So this is the matrix for A square. So now let's substitute in the equation. So A square minus 5A plus 7I is equal to 0. Now I will start substituting. 8, 5 minus 5, 3. Minus 5 into my A matrix is 3. 1 minus 1, 2 plus 7 into 1, 0, 0, 1 is equal to 0 matrix 0, 0, 0, 0. Fine. So now I will be multiplying these numbers inside the matrix. So 8, 5 minus 5, 3. So 5 3s are 15. 5 1s are 5 minus 5, 10 plus 7, 0, 0, 7 is equal to 0, 0, 0, 0. So now I will be adding these two matrices, that is this matrix and this matrix. So 8 plus 7 is 15, 5 and here minus 5, 10. Minus 15, 5 minus 5, 10 is equal to 0, 0, 0, 0. So if you look into these two, so now I'm going to take this minus sign inside. So this will become plus. So minus, minus, plus, minus. So now if you check these two matrices, so these two are same with negative sign. So I will have 0, 0, 0, 0 is equal to 0, 0, 0, 0. So therefore LHS is equal to RHS. So since the first part is proved, we have to find the second part. What was the second part? We have to find A inverse. No. So in previous sums and all, we used to find A inverse with determinant and adjoint of a set or matrix, isn't it? So but here we will not be using that determinant and adjoint. So instead we will be using the same equation. What was the equation? A square minus 5a plus 7i is equal to 0, isn't it? So now what I'm going to do is that I have to have A inverse, isn't it? I don't have A inverse anywhere, so I have to find my A inverse. So I will be multiplying, post multiply A inverse on both the sides. So A square can be written as A into A, and here A inverse minus 5 into A inverse plus 7i into A inverse is equal to 0 matrix into A inverse. So I have multiplied throughout by A inverse. Okay. So each and every element I have multiplied with A inverse. So if I take this A inverse out, it will be A inverse into A square minus 5a plus 7i is equal to A inverse into 0. So those two will get cancelled, so that I will get the previous step. Okay. So now what I am going to do is that I will be grouping. So this, and this. Okay, so now what all properties we'll be using, I'll just say already we have learned these properties in the introduction part. So A into A inverse is equal to I, and I into A inverse is equal to A inverse I into A is equal to A. So these are the properties we will be using, and one more is that 0 into A inverse is equal to 0 matrix only. Okay, so here A into A inverse is I, no. So AI minus 5 into A inverse is I plus 7 into I into A inverse is A inverse only is equal to 0 into A inverse is 0. So now what I will be doing is that I will be taking these two terms to my right hand side. So I will have 7A inverse is equal to, so here this will become plus, no. So plus 5I, A into I is A only. So minus A. So this is the required equation for finding A inverse. So we know what is I and what is A, isn't it? So we will be substituting there. So 7A inverse is equal to 5I minus A. So 7A inverse is equal to 5 into, what is the order over there? There it is 2 by 2, no. So 1 0 0 1 minus, what was my A? My A is 3 1 minus 1 2. So this is my matrix, no. So 7A inverse is equal to, so I will be multiplying this inside. So 5 0 0 5 minus 3. So I will be taking this minus sign inside. So this will become plus minus minus plus minus. So minus 3 minus 1 1 minus 2. So now I will be taking 7A inverse is equal to 5. This is plus, no. So 5 minus 3 is 2. And here it is minus 1 1 3. So I will be taking this 7 to my denominator of the RHS. So A inverse is equal to 1 by 7 into this matrix is 2 minus 1 1 3. So if you take the adjoint and determinant, also, you will get the same answer. But if they have given an equation and asking to find the inverse, means you have to follow this method. You will be multiplying by A inverse on both the sides, whatever equation it is, whether it is a quadratic equation or linear equation or cubic equation, you will be multiplying throughout, that is post multiplying throughout by A inverse. Then we will get a term with A inverse. With that A inverse, we will be finding the required matrix. So this is the answer over. Question 15. For the matrix A, show that A cube minus 6A square plus 5A plus 11I is equal to 0. Hence find A inverse. So just like previous question, this will be part 1 and this will be part 2. So we have two parts in this question. So first we will be doing part 1. So part 1 let's do. So first we have to find A cube, no. So A cube can be written as A into A into A. Okay, so now what I will do is that I will be taking A matrix twice. First I will find A square 3 into A. So first I will be taking the rows of the first matrix 3 into A. Okay, you should not forget this A, and I'm going to multiply with the column. So now I'm going to add these into A. Into A. So this is my A square. Now I'm going to multiply this. So 4, 2, 1 minus 3, 8 minus 14, 7 minus 3, 14 into what is A, 1, 1, 2, 1, 2 minus 1, 1 minus 3, 3. So now I will be multiplying these two. So now I will be multiplying. So this first element with first row. So now I will be adding this. So now I'm going to substitute in the equation. So a cube minus 6a square plus 5a plus 11I is equal to 0. So now I will be multiplying these numbers and all inside. So now I will be adding these three, okay. So now I'm gonna take this minus sign inside. So I will have plus, minus, 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 plus, minus, plus, minus, plus, minus, minus, plus. So now if we just look into these two, these two matrix has the same element, but whatever is positive here, it is negative here, and whatever is positive here, it is negative over here. So therefore I will write 0 0 0 0 0 0 0 0 0 is equal to 0 0 0 0 0 0. LHS is equal to RHS. So here the first part is proved. So now let's move on to the second part. This is a given equation, isn't it? So here, from here only we have to find the A inverse. So as I did for the previous sum, I will be doing the post multiplication on both the sides with A inverse. So A inverse into A cube minus 6A square plus 5A plus 11I is equal to A inverse into 0 matrix. So now I'm going to multiply these inside. So now I will split this A cube. So A into A into A into A inverse minus 6A into A into A inverse plus 5A into A inverse plus 11 into I into A inverse is equal to, anyways, 0 into something is 0. So here 0 matrix into A inverse also is 0 only. So 0. So now I'm going to group this. So now we have already saw this properties, no? So A into A as it is I will have. So A into A inverse is I minus 6A into I only, A into A inverse, plus 5A into A inverse is I, plus 11I into A inverse is A inverse is equal to 0. So in the next step I will have A square I minus 6, A into I is A only, plus 5I minus plus 11, A inverse is equal to 0. So now everything I'm going to take it in terms of A inverse. So 11 A inverse is equal to minus A square. A square into I is A square plus 6A minus 5I. So now I'm going to substitute all the values. So 11 A inverse is equal to minus of what? So 11 A inverse is equal to, I will take this minus sign inside. So I will have plus 6, 6, 6, 6, 12 minus 18, 12 minus 6, 18 minus, so I will be taking this inside. So 5, 0, 0, 0, 5, 0, 0, 0, 5. So now I will be subtracting. So 11 A inverse is equal to, so minus 4 plus 6 is 2, minus 2 plus 6 is 4, minus 1, 5, here 3, 4, minus 4, 5, minus 3, 4. So here I will take it inside. So minus, minus, minus. So plus, minus 5, 0, 0, 0, minus 5, 0, 0, 0, minus 5. So now I will be subtracting. I will be taking this 11 here. So A inverse is equal to 1 by 11 into. So 3 minus 3, 4, 5, 3, minus 1, minus 4, 5, minus 3, minus 1. This is the answer. If you have any doubts, mention it in the comment box.
Like, comment, share, and subscribe.